Okay, so as I say, I'm Miles Berry. I work at the University of Roehampton. I'm sort of the vague equivalent to associate professor in US terms. We call it principal lecturer. I'm training the next generation of outstanding teachers in my day job, but Roehampton are generous with my time. They let me go out and do other interesting things as well. So I was part of the panel who drafted the English computing curriculum, our national curriculum for computing, and have been involved in a lot of the professional development and resourcing projects that there have been since then. All of these slides are online. We start with the premise that teaching really does matter. If you want to improve the quality of an education system in broad terms, the only way you can go about that is to improve the quality of the teachers who are delivering that education system, who are providing that curriculum. This applies to computer science education. If we want an outstanding computer science education in every school, then you need an outstanding computer science teacher in every school. And there are essentially two routes to that. Either recruit better people into the profession, which will take about 40 years to filter its way through, or do something about training the people you have there. And both approaches together is probably the best way to do it. So as many of you know, England has put computing onto its national curriculum. Every local authority-supported school has to teach computing from 5 to 16-year-olds, whatever that may mean. At the same time as doing that really quite radical thing, we've also got a government who's stepped back from the implementation phase of this. The phrase they use, government should only do what only government can do. So one of the things only government can do is legislate what should be taught in schools, but they've kind of assumed that other people would step up to the mark when it came to professional development, and it came to producing resources, and it came to, training teachers and making sure that this happens. So let's start with the professional formation side of this. And we are really struggling to recruit when it comes to getting computer science graduates to train to become teachers. So over the last, 5 years or so, we've been around about 65% of the places that are funded for folks to train to teach computer science in secondary schools seem to be filled. 495 folks training to teach computer science in secondary education at the moment. We had funding for another 200 or so, but the folks never turned up. Now, why is that? How come somebody with a degree in computer science chooses not to become a secondary school computer science teacher? Perhaps there are other career opportunities available to them. We've done something to try and persuade more to join the teaching profession from that sort of background in computer science. It doesn't have to be a new graduate. It could be somebody who's done 20, 30 years in the IT industry and the software industry, doing a second career at that point. So we have the BCS, British Computer Society, scholarships for computer science teachers, £27,500, tax-free for the training year, £27,500. That's about $27,500, the way our exchange rate is going. We also have tax-free bursaries for folks who've got a good degree in computer science or doctorate in computer science to train to become computer science teachers. So we're trying to tackle that supply side problem. What should a computer science teacher know? We've put together a list of requirements for that. So if you want to become a computer science teacher, what subject knowledge should you bring to the course there? We've got a range of things. So this includes both primary and secondary. I'll give you a moment to copy down the detail from the slide there. No. Okay, let's move on. In primary rather than secondary, we have a big subject knowledge gap. So at the University of Roehampton, our primary and secondary trainees for the last couple of years here, when they start the course, we do an audit. We ask them to evaluate themselves. How much do you know about this? And bizarrely enough, our new students say they're reasonably adept at using a range of social software. I have, about 4/5 of my students who describe themselves as proficient or expert when it comes to social software. Far, far fewer able to use spreadsheets, far fewer able to work with video, far fewer able to work with data, and look, a vanishingly small proportion who profess any knowledge, any expertise when it comes to programming. And these are the folks who are going to have to go into school and teach all primary pupils how to program computers. I have 3/5 of my new entrants who say they've never done any programming before. If they're going to teach the next generation of primary school pupils how to program, they need to learn to program themselves, I would argue. We get an even more disturbing picture when we ask them to evaluate their own knowledge and understanding of some of these big ideas here. So do you know about algorithms? I have 1%, if that, of my new students who describe themselves expert, and I have, that's going to be about 80% of them who say none or very limited or only a basic grasp. My favourite of this is logical reasoning, where I have more than half of my students say they have never used logical reasoning. You have to wonder how they chose the course, you really do. So we get a year with our postgraduates, we get 3 years with our undergraduates to turn that round, from that very low baseline to being able to go into primary school and teach this subject confidently, and we hope competently. And some of this happens on placement, some of this happens with others at Roehampton. Lovely story from one of my PGCE students. I had heard of Scratch before, but this was the first time I'd actually encountered this program, and I have to say I was a bit overwhelmed. Nevertheless, the children were enthusiastic to show and talk me through the process of programming in Scratch, a program which generally all the children were confident and greatly enjoyed using. My pre-Scratch nerves soon disappeared. I was extremely impressed and surprised by the children's confidence and independence using Scratch, but this lesson highlighted to me how important it is for me to develop my own knowledge of programming. Not that they're all quite so aware of the relationship between pedagogy and subject knowledge as that student is. Okay, so that's the professional formation side. Professional development matters as well. The difference between a teacher who knows what they're doing, a quality teacher, and a low-quality teacher is about a year's progress. So, get compared to 1 year's average progress with a good teacher, children will make about a year and a half's progress. With a poor teacher, it's down to half a year, okay? Losing those to the profession is one approach. Training them so that they get better at teaching is the other. We now have a set of national standards for professional development, which includes lots and lots of really good ideas like focusing on improving pupil outcomes. That should be part and parcel of what professional development does. Robust evidence and expertise, both collaboration, the community of practice, as well as the expert challenge, the expert input. And that applies to computing education, professional development, just as anything else. So much of what we've done in England, in the UK, is through Computing at School, which is our community of practice, our 27,000 strong membership organisation. Lots of teachers, those teachers who are teaching computing, members of Computing at School, together with academics, together with folks from the industry. It's a wonderfully vibrant community with a whole range of events happening pretty much every day of the week there. We have our local hub network spread throughout the UK there. For professional development, I suppose we take as a starting point the Mishra and Kohler TPACK model of saying that teachers' professional knowledge has 3 components to it. The pedagogical knowledge, the how to teach, the content knowledge, the what to teach, and in this realm, perhaps also the technological knowledge, how to use these tools. We've taken a much more okay, all right, that's just 2 minutes up, okay. We've taken a much more simpler approach to this. So removing from this the interaction effects, we're saying outstanding teaching of computing involves 3 components: pedagogy, your tech skills, and your CS knowledge. And we've looked for the low-hanging fruit, and we've said that teachers by and large know how to teach, they know how to use the technology, but they lack this understanding of computer science subject knowledge. So that's what we focused on, because subject knowledge itself really matters. The most effective teachers are those who have a deep understanding of the thing that they're actually teaching. So many of the resources which Computing at School has worked to produce, things like barefoot computing for primary, things like the tenderfoot thing for secondary school teachers, and our quick start guides have focused not so much on the how to teach, but the what to teach, the knowledge of computer science. Has this been effective? I hope so. When we did surveys, so YouGov did the survey before the implementation of the curriculum, 33% of teachers said they were confident with this. Then last summer, Ipsos Mori, 81% of British teachers saying they're confident teaching it. Many of us think that these figures are overly optimistic, but there's some cause for celebration there. We have a network of excellence in teaching computer science, 10 universities throughout England acting as the regional centres for that, each supporting a number of master teachers. You'll have to forgive the gender-specific language there, but the teachers who know how to teach and have some computer science knowledge, taking responsibility for passing that on to the teachers in their schools. Is this having an impact? Yes. According to the independent evaluation, CAS is making a significant difference to the implementation of the new computing curriculum. I think they mean a significantly positive difference to the implementation of it. Hi, Sue. So Sue has put together for the British Computer Society this brilliant certificate in computer science teaching, brilliant model of continuing professional development, accreditation, which has 3 components. Yes, take part in CPD, at least 50% of which has to be face-to-face, but also do some programming. Program something yourself. To teach computer science, you kind of have to know how to program. And then start to get involved in the research, do the little action research project, see what happens when you try particular pedagogic approaches. It would be wrong to leave you with the impression that all of this is happening through computing at school. Other organizations are available. So the Raspberry Pi Foundation has a really very, very effective professional development program called Pi Academy, 2-day course. First day, learning about what you can do with the Raspberry Pi, a little $35 computer. The second day, making something with others to run on a Raspberry Pi. Code Club Pro, like Code Club, but for teachers. And of course, the MOOCs, the English or UK MOOC, Future Learn, has a number of computing courses. Thank you very much. Okay, thank you.